Hello everybody and welcome back to Maths Miss Buick. This is the fourth video where we explain polar form. Polar form is r cos theta plus I sin theta. R is the modulus and our theta is our angle. So in this question we have z is equal to -√3 negative I. So let's begin by plotting the complex number to see what quadrant it lies in. So we're plotting our real and our imaginary axes here. So here's our real and there's our imaginary. Well, -√3 on the real will be over as far as this way, and then the negative I is down this way. So that shows us that our complex number is in the third quadrant. And let's label our reference angle alpha. So let's begin by finding our r, which is the modulus. So r is equal to the square root of a squared plus b squared. So we have -√3 to be squared plus -1 to be squared. We get √4, which is 2. So our value, our modulus, is 2. Next of all, we're going to find our alpha value. Tan inverse of b over a. So in this question, our b is our 1 and our a is our √3. Notice there I haven't mentioned the negatives in front of the real or the imaginary, as the a and the b here represents the opposite and the adjacent, as in tan is o over a, and o over a are lengths from a right angle triangle, so therefore we can't have a negative length. So let's only put in the positive values here. So when you type in tan inverse of 1 over √3 into your calculator, you get pi over 6. So our alpha value is pi over 6. Now, let's look at our rule. Well, the rule is theta is equal to minus pi minus alpha, or our reference angle. So let's carry out this. So we have minus pi, so which implies here, minus pi over 6. So when we do this out, we get, we'll leave the minus here for the moment. We get, well, pi minus pi over 6 is 5 pi over 6. And then, of course, we multiply in our negative. So we have -5 pi over 6. And this is the value of our theta. So our r value is 2 for the modulus, and our theta value is -5 pi over 6. And this is what we put into our formula up here, our polar form. So r is 2 cos -5 pi over 6 plus I sin -5 pi over 6. And we're done. This is our value of our polar form.